All right, y'all, so we are on the day 5 notes, which is more solving logs, and it's actually also solving exponential equations. You've done this before. So if you have 3 to the x power equals 81, what you want to do is see if you can make the larger number into a power of the smaller number. So 81 is the same thing as 3 to the 4th power. So you're trying to rewrite one of the numbers as a power of the other one if possible. So once you have it as 3 to the x equals 3 to the 4th, you know if you set the exponents equal to each other, your answer has to be x equals 4. Okay? So you get the bases the same, and then you solve your exponents. So set the exponents equal and solve. That's kind of your goal here. All right? So look down here at example B. Before you can solve it, you have to have the same base. So I can rewrite 16 as a power of 4. So this side I can leave as 4 to the 3x plus 1. You rewrite the 16 as 4 squared. Because 4 squared equals 16. And then whatever already was the exponent, you multiply right here. Okay? So I've just changed 16 into 4 squared, and then I put the exponent that was already there. Once you have the same base, now you solve the exponent part. 3x plus 1 equals 2x minus 2. Subtract over here. Subtract the 1. So I get x equals -3. I don't have to worry about extraneous solutions and things like that because you're allowed to have negative exponents when you plug it in, okay? So we don't have to worry about anything being extraneous, right? This next one, I've either got to turn 5 into a power of 1 over 625, or I can turn this into a power of 5. And it's actually going to be this one. If you ever see a fraction, think of it as this big number right here. Is that a power of 5? And it's usually going to work out that it is. So actually 5 to the 4th power is 625. Okay. So if I want to turn 5 to the 4th power into this, I could call this 5 to the -4th power. So let's review why that is. A negative exponent drops it to the bottom. So 5 to the -4th is the same thing as 1 over 5 to the 4th, which is this. So 5 to the -4th is the same as that, which is 5 to the -x squared. Now I have the same base. I've made them both into powers of 5. Once you have the same base, you set their exponents equal. Divide by -1, I get 4. So x equals plus or minus 2. Whenever you square root, don't forget your plus or minus. Negatives are okay, so both answers work. Okay? So again, your goal every time is to get the same base. So if you look at letter D right here, just a minute, pause. All right. Tinsley, no. So you have the same base right here. So since I already have an E, as the base, you set the exponents equal. Okay. Tinsley, shh. All right. So you have the same base, set the exponents equal to each other. I moved everything to one side, so now I need to solve. So I need to factor that. Multiplies to make 3, adds to make -4. X minus 3, x minus 1. So I get x is 3 and x is 1, and that is going to be our answer. Okay. Sorry for the dog barking. All right, next one for letter E. I've got to try to make these both into the same base. It's typically going to be the larger number that you see. Now in this problem up here where it was 1 over 625, you saw 625. You can turn 625 into a power of 5. I can turn 27 into a power of 3. So this side is going to stay the same. That's 3 to the x minus 2 equals 3 cubed. Okay. Now that I have the same base, set them equal. So x equals 5. So that one was pretty easy. Again, the whole point of this is to get the same base. And again, we have another E problem. Those of you taking calculus, you need to get used to seeing E's because they're going to be in a lot of our work. So just get used to using them. They're just a number. Don't worry about it. But I have the same base. They're both E. Set the exponents equal to each other. This one's going to be easier if I move the x squared over here. So it makes it positive. Factor that. Let's see, x plus 3, x plus 2. So my answer to this problem would be -3 and -2. Running out of room. Okay. All right, so the whole point, if you're trying to solve an equation and it's in exponential form, you have to try to get the bases the same. All right. If you can't get the bases the same, which is this side over here, we have to do something else. And the reason I can't get the bases the same is because I can't rewrite 13 as 2 to the something power. There's no, like 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16. I never can get to 13. So if you can't get the bases the same, this is the, probably of all the log ones that we've done, this is the hardest to remember to do because you just have to know, anytime this happens, you have to take the log of both sides. Okay? Take the log of both sides. And all you do to do that is you write log in front. Log of 2 to the x equals log of 13. I just literally wrote log in front of this and log in front of that. But before you actually can solve this, we can't leave an exponent here. So if you remember from when we were doing properties, an exponent on a log jumps to the front. So this really becomes this, x log 2 equals log of 13. Divide both sides. I'm trying to solve for x, so I can divide both sides by log of 2. Now, if you're doing a problem and it says you cannot use a calculator, this is all you can do. You can't solve this any further. The answer is log 13 divided by log of 2. Kinder, I need you to stop. Okay? If the question says you're allowed to use a calculator or write your answer as a decimal, what you do in your calculator, you can type in, there's a log button right down here. You see that? There's an actual log button you can use. There's also an LN if you need that one. You hit the word log, and I say the log of 13. Okay? Actually, what I'm going to do, I'm going to go back. Instead of doing it that way, y'all remember that alpha y equals gives you the fraction bar? Let's use that one. Plus, that's just a good tool to remember. It's alpha y equals, and then it says like n over d, hit enter, and it gives you the fraction bar. So now let's put it here. So I'm going to do the log of 13 on top, divided by the log of 2 on the bottom. And it's going to give you the decimal 3.7. So this is the real reason that we have logs, is because we need a way to solve the equation here. I need to know 2 to the what power is 13. I wouldn't have randomly come up with 2 to the 3.7 power. Okay, so by having the logs programmed into the calculator, as long as you can get it set up correctly, you can solve it. And I'm going to show you this. I got x is 3.7. In my calculator, if I raise 2 to the 3.7 power like that, I get 12.996, which is basically 13. Okay, so this allows you to solve logs that don't come out to be a perfect number, that you don't have a perfect root that you can make it. All right, I can't turn 13 into 2 to the something, so my only way to solve this one is by doing this. So you take the log of both sides, okay? So we're gonna do the same thing here. I can't turn 15 into a power of 5. At first it looks like maybe I can, but 5 squared is 25, so I'm already too big. So what I have to do, I write it as log 5 to the x equals log 15. You literally write the word log in front of both sides. Then you have to get the exponent to the front. So it's x log 5 equals log 15. Divide both sides by log 5. So with no calculator, that's where you would stop. Log 15 divided by log 5. But in the calculator, remember, alpha y equals, hit enter, and now you get your fraction bar. So I want the log of 15 divided by the log of 5. That means if I raise 5 to the power of 1.68, I'm going to get approximately 15. So it allows you, logarithms allow you to solve for exponents that are unknown. So my answer was 1.68. And that's approximate because it's rounded. Okay. Before I go on, I want to point something out. Do y'all notice anything about these two problems? My problem started off like this: 2 to the what power is 13, and I don't know the answer. 5 to the what power is 15. If it's something that you can't figure out, look what I ended up doing. Here, I divided log of 13 divided by the log of 2. Here, log of 15 divided by the log of 5. So you might notice that to be a shortcut. All right. If you don't notice it, it's okay. All right. All right, so let's do this next one. Again, I'm trying to solve this equation for x. So I want to start with getting the exponent, the e part by itself. So I want to subtract 5 from both sides. So now I'm here. Negative 3 e to the x equals negative 3. Divide the negative 3 off of here. So now I have this, e to the x equals 1. Instead of having to actually solve this one, I just want you to think about it. What exponent always gives you an answer of 1? You've probably heard me say this a million times. Anything to the 0 power equals 1. So that means in this problem, you can just think through it. It has to be 0. Because if I plug 0 in for x, e to the 0 power is 1. So that one you don't really have to do anything else to. Okay? All right. This one, before we start, one thing I want you to realize, you can never distribute a number or multiply a number by another number that has an exponent on it. So I cannot make that 12x. What I have to do instead is divide by the 4. So now I have this problem. 64 divided by 4 is 16. If you remember the shortcut from above, anytime you have this, can I actually solve this? Does 3 to the something really equal 16? No. I can't rewrite 16 as a power of 3. 3 squared is 9. 3 cubed is 27, so I never can get to 16. All right? So if we look up here, if I have a problem like that, remember the shortcut, it ends up being the log of this number divided by the log of that number. So I'm going to guess this is probably going to end up being log of 16 divided by log of 3, but we'll work it out. You can't get the bases the same, so it's log of both sides. Remember, your x is going to jump to the front, so you get to here, and then you're going to divide by log of 3. So in your calculator, you're going to type in log of 16 divided by log of 3. Do that in your calculator. Alpha y equals log of 16 divided by log of 3, 2.52. And what that means, remember, is if I were to work this out, 3 to the 2.52 power, I would get 16. So logarithms allow you to come up with that exponent that you can't figure out, okay? The only way you can get this exact answer is by having a calculator that will do this, all right? Let's go on and turn the page. All right, on this one, all right, so there's this little thing called the change of base formula. If you look at this right here, what we do is we say, okay, I want to solve this problem. So I think of it as having an x at the end. If I turn this into an exponential equation, this is the kind that we swoop because there's log on one side. So I say 3 to the x equals 16. Remember those kind? You swoop it like this. 3 to the what equals 16 is what I'm trying to solve. I don't know that answer. I can't figure it out. I can't turn 16 into 3 to the something. This is the last problem that we did, very similar. So I log both sides and I end up with this. So x would equal log of 16 divided by log of 3. So if you look up here at this change of base formula, it's saying anytime you start with a log problem like this, it's always going to be the log of this number divided by the log of the base. So the big number on top. So this one ends up being log 16 over log 3. That's what you put in your calculator. This one, log 22 divided by log 5. This one, log 12 divided by log 7. Log 112 divided by log 4. If you put that into your calculator, you're going to get the decimal that it turns out to be. Okay? So this is actually the same problem we just did. Log of 16 divided by log of 3. This was 2.52. This one, if I do log of 22, hold on, go back. Alpha y equals log 22 on top divided by log of 5 on bottom. You get 1.92. All right, I want to show you a shortcut. Your calculator, because we're fancy now, you have a button that will actually do this. If you hit the button alpha window, so what I did to get here again, I hit alpha and then I hit the word window and this screen right here came up. If you look down here at number 5, so alpha window number 5, choose number 5, it gives you log, it gives you a log that you can type in and solve. So if I type in right here, log base 5 of 22, like that, I get the same answer as doing log of 22 divided by log of 5. So it's a shortcut. Since you get to use a calculator for this, you can type this exact thing into your calculator. So I want you to make a note of how to do that. So either you can do it like this, or you can do this. You can type your numbers into your calculator like that. And the way that we get there is alpha window, and then you choose number 5, alpha window number 5, which says log base. If you have a fancier calculator than I do, it may actually just give you these boxes right here. It just may say log. If your calculator will not do this, there's some that are older like TI-83s or some that haven't been updated, or if you're using an app, it may not have this feature. And if that's the case, you would have to do it like this. Okay, so it's good to understand this because you might be in a class where you don't get to use a graphing calculator that has this feature, so you would need to be able to do this. Okay, but scientific calculators are going to have the log button, so you could always solve it this way. All right, anyway, this thing right here where you change it from this to this is called the change of base formula. All right, but again, I don't care if you use this function of the calculator. where you write it just basically as exactly as given. Okay, so that might help you out on your math lab some. So again, it's alpha window to get there. Okay. All right, we just have a little bit left on this. What we're going to do here is we're going to solve some logs, but if you notice there's no equals in there, what they're looking for whenever they just give you a log with no equals, they're looking for what number, if you take 2 to what power do you get 4? That's what they want you to solve. So in your mind, you're going to think 2 to the what power equals 4. Because what they're asking you is log base 2 of 4 equals what? So you're saying 2 to the what power equals 4. We're doing the little swoop. So if you don't see an equals, you're looking for this missing exponent right here. So 2 to the what equals 4? Our answer is 2. And you don't really need to write x equals 2 because there wasn't even really an x in the problem. So here on this next one, I'm thinking 3 to the what power equals 1 over 81. So whenever I see a problem like this, this is what I'm thinking. I'm looking for that missing thing that was out here. 3 to the what equals 1 over 81. Well, let's think about this. 3 to the 4th power is 81. So if I wanted to end up in the denominator, I would have to put a negative on it. So my answer to this problem would be -4. Because 3 to the -4th power would drop the 3 to the bottom to the 4th power. So it ends up putting the 81 on the bottom. So if you ever see a fraction like this, you're looking for a negative exponent. All right. This says log base 7 of the 5th root of 7. So what you can think of this one as 7 to the what equals, instead of writing the 5th root of 7, the 5th root of 7, remember, is 7 to the 1/5 power. You need to get really used to changing roots or radicals into fractions and changing negatives into denominators, okay? So I'm saying 7 to the what power equals 7 to the 1/5. Well, that means this one's kind of obvious. The answer right there has to be 1/5. Here, I'm saying 5 to the what equals, I need to go ahead and change 125 into a power of 5 would make this easier because I'm doing this. So do you see how this is the problem? We don't have the same base like we did over here. So I need to rewrite 125. I'm going to come up here and do this right here. 125 is 5 cubed. So I have 5 cubed to the -3rd. So I multiply that. So I end up having this problem, which now has the same base. So my answer is -9. Okay, so you might need to look at that one for a second. That one's a little bit confusing. I wrote it as 5 to the what equals 125 to the -3rd. I changed the 125 as 5 cubed. So I had 5 cubed to the -3rd, which really makes this 5 to the -9. So -9 is my answer. Okay. This one, this you should be able to do in your head. You're thinking 5 to the what power equals 25. So my answer is 2 because 5 squared equals 25. 3 to the what power equals 3? 1. So anytime you see a log problem and you have just the base and the whole number, you're looking for the exponent to put on that base to give you the answer. Okay. This one is telling you when x is 1, they want you to plug 1 in for x. So they want you to solve this problem. Log base 6 of 1. Okay. So 6 to the what power, this is what I'm trying to find. 6 to the what power is 1. We talked about this a second ago. Anything to the 0 power is 1. So that means my answer is 0. This one, they want you to plug in 1/2 for x. So it says x equals 1/2, so I'm putting 1/2 right there. So what I'm thinking in this problem, is 2 to the what power equals 1/2. So 2 to the first power is 2. So what if I make it 2 to the negative first power? Do you see how that would turn this into having a 2 on the bottom? So that means -1 is my answer. Okay. All right. And then I mentioned this a little bit earlier. I told y'all to write it down. I don't know if it was even today or if it was on the day before notes, but whenever you just have this right here is asking you what the base is. Logs have a base of 10 unless something else is given. Natural logs, which are these ln's, they have a little e as their base. So log is always 10, ln is always e. If it's not given, that's what they are. Okay. So this is right here is the same as we were doing up here. So if you don't see a number down here, you have to add your 10 or whatever down there. So I'm doing this problem just like I did before. I'm thinking in my head, 10 to the what power equals 1,000. Okay. So log base 10 of 1,000 is going to be 3 because 10 cubed is 1,000. Putting an e down here. So I'm saying in this problem, e to the what power equals e squared. When you think of it that way, it makes sense that the answer is 2. Put your little 10 down here. 10 to the what power equals 0.01. Instead of writing 0.01, write that as 1/100th. 0.01 is the same thing as 1/100. So what you're trying to decide is what exponent would turn 10 into 1/100th. Well, I say I could turn 10 into 100 by making it squared. So if I want the 100 to go to the bottom, I just have to make the exponent negative. So my answer is -2. 10 to the negative second power is 1/100. That's what I'm looking for. Okay. For letter D, anytime that you have an ln, your base is e. So I'm doing this in my head. E to the what power equals 1. So the answer would be e to the 0 power. So my answer is 0. So the ln of 1 is 0. Okay. Log of 1. Log is always base 10. So 10 to the what power equals 1. Anything to the 0 power equals 1. So my answer is 0 again. Okay. Here. Let's try to do this without writing it down. 10 to what power equals 10? The answer to this problem is 1. I'm looking for the exponent that goes on this little base to give me this answer right here. Okay. So 10 to the first equals 10. This one, I'm going to write this one down because it's a little more confusing. Anytime your answer is 1, the only exponent you could have had is a 0. Anything to the 0 power gives you an answer of 1. This one, I'm saying a to what power gives me an answer of a. Isn't a to the first power equal to a? Yes. This one, a to what power equals a to the r power? A to the what equals a to the r? The answer would have to be r. ln of 1, I think we already did this one right here. Again, anytime that's a 1, your answer has to be 0. So see, all of these that have a 1 right here, all of these, our answer is 0. We're trying to find an exponent that gives us an answer of 1. The only exponent that gives you an answer of 1 is 0. ln of e, put your e right here. So you're thinking this, e to the what power equals e. So it's got to be 1. This one is a pretty common one that we use a lot in calculus. ln of e is 1. We also do ln of 1 is 0. We use that one a lot. These are pretty important for calculus. Being able to switch them around is pretty important because we do use a lot of e's and ln's in calculus. All right. This one right here, you put your little e right here. E to the what power equals e to the x. My answer then is x. Okay. So anytime that you have a log problem, let's say you have a base and you have a number right here and they want you to solve this log. They don't even have to put an equals on it. What you're trying to do is figure out the number you would have to take this to, what power. 3 to the what power gives you 9, and that's your answer. The answer to this log is 2. 3 squared equals 9. Okay? So you're looking for the exponent that goes right there to give you this number. That's how you can answer a log problem. Okay? So I'm going to kind of recap this real quick. What we've done on solving equations, all right? We had the kind where you have log of something equals log of something else. All you do is cross them out and you solve what's left over. So you have log on both sides. Then we had the kind where you had to condense. So that was something like, let me show you one that's already done. You have ones like, something like that. You can't cross off the logs until we condense it first. Subtraction turns into division. So you have to condense first, and now we have log on both sides. Then you just solve what's left over. Okay, and these are the kind we have to plug back in and make sure we don't get a negative. Okay, actually same thing with these. So you have log on both sides where you can cross them off. Sometimes you have to condense first. Okay, then we had the kind where we only had log on one side. And that was something similar to what we've just been doing. Maybe like that. If you only have log on one side, that's when you have to swoop. So I would say 3 to the second equals x. So x would equal 9. And the x could be in any of these places. It doesn't matter. But if log's only in one spot, you have to swoop to solve it. Okay? Then we have the kind where we had something like 3 to the x equals 15. There's no logs in the problem at all, but we can't figure it out. If you can figure it out, great. If you can make this into a power of 3. But if you can't do it, that's when you log both sides. Log 3 to the x equals log 15. Bring the x to the front. Divide this under here. Log 15 divided by log 3, and you go to your calculator and you get a decimal. So these are the different ways that you can solve logs. Log on both sides. A little bit harder with log on both sides where you have to condense first. Log only on one side where you have to swoop. And no logs where you have to add log to both sides. Okay? So that's the basic idea of the different ways that you have to solve your logs. All right? Thank you.